In this lesson, we will define and explain directed distance, also known as displacement vector, from point A to another point B. Let's get started and suppose that the coordinates of point A and B are x1, y1 and x2, y2. Suppose coordinates of A are x1, y1 and B the coordinates are x2 and y2. Then the displacement vector from A to B can be defined as AB, and then we place an arrowhead. A is the initial point and B is the terminal point, and the arrowhead indicates the direction that the displacement vector is from A to point B is equal to x2 minus x1, y2 minus y1. And on the grid we can denote this as, suppose this is the point A with coordinates x1, y1, and then there is another point, let's call this as B, with coordinates x2, y2. Then you can draw the line from point A extending toward point B, and this is the vector AB. Now in part 1 of the question, we are required to find the displacement vector starting from point A 2, 3 and going to 7, 5. 2, 3 to 7, 5. 2 and 3 is this point. So here A is 2, 3 and B is 7, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4 and 5. This is the end point. So if this is point B, that is 7, 5, then this vector AB is the required displacement vector. Then if A is equal to 2, 3 coordinates and B is 7, 5, then displacement vector AB displacement vector is equal to x2 minus x1, y2 minus y1. And like slope, we can name the starting point as x1, y1 and ending point as x2 and y2. Like we said in the slope, in slope and in distance formula, it was okay if we name the point A and B with x1, y1, x2, y2, or we reciprocate, but in displacement vector, the starting point must always be given the name x1, y1, and the terminal point must always be given the name x2, y2. So here x1 is equal to 2, y1 is 3, and x2 is equal to 7 and y2 is equal to 5. Therefore, we have this equal to x2 minus x1, which is x2 is 7 minus 2 and 5 minus 3. So the required displacement vector would be 5 and 2. This would be the vector AB. And now what is the next question? The next question is find the magnitude of vector AB. The magnitude of vector AB, that's the question number 2. Magnitude of vector AB, which is also called the displacement vector, and you can place half arrow or full arrow on the top of AB. Magnitude of vector AB denoted by, this is denoted by, we denote the magnitude by placing bar around the vector, which makes it scalar quantity and doesn't require the direction, but this would be the magnitude AB would be equal to x component square, which is 5 and square, plus 2 square and then square root. This is the magnitude of the vector. That is again 25 plus 4, and this will become equal to 29 square root. 29 is a prime number, therefore it cannot be simplified. So here we have AB vector and AB vector, and it is their magnitude. That's why we have bars around them. And the next question, we are required to find a unit vector. Now what is a unit vector? Unit vector is a displacement vector which has magnitude equal to 1 and represents the direction only. So if we want to find out the unit vector in the direction of vector AB, third, a unit vector is a vector which has magnitude of 1 and represents the direction only. Here, if we want to find a unit vector in the direction of vector AB or the displacement vector AB, we can name it as AB, but this time we are not going to place the arrow on it, rather we put this symbol. This is a symbol for a unit vector, is equal to the vector AB divided by the magnitude of the vector AB. So any vector when divided by its own magnitude gives us a unit vector in that direction. So this is equal to, what is the magnitude? That is 1 over 29 square root, and the vector AB is 5, 2. Therefore, this unit vector is in fact equal to 5 over 29 square root, comma 2 over 29 square root. So this is a unit vector in the direction of given vector AB. If we have another question, Here it says find a vector of magnitude 5 in the direction of vector AB. And now if we want to find out a vector with magnitude 5, we have no trouble multiplying this vector with 5, and that should give us a vector of magnitude 5. So the last part, this is fourth vector of magnitude 5 in direction of vector AB, either in this direction or AB unit vector, because both have the same direction, is equal to 5. That is, just multiply, because the unit vector has magnitude 1. If we multiply it with 5, that will be equal to 5. So 5 times AB unit vector, which is equal to 5 times 5 over 29 square root and 2 over 29 square root. So now if we multiply 5 inside, we will have 25 over 29 square root, comma 10 over 29 square root. This is a vector of magnitude 5 in the direction of unit vector AB or in the direction of displacement vector AB.